Hello, Bhavana. I'm audible. Yeah,
Hello, sir. Good evening, sir.
yeah, good evening, Bhavana.
Good evening, sir.
So, which topic I have to take for you? From which chapter we should start?
I didn't started with any topic, sir. So it's up to you.
Okay, so grade 11th, is it?
Yeah, yes, sir.
Okay, so I'll be starting with the unit and dimensions.
Okay, sir.
Wait. Check something, share with you. Okay, I've shared my screen. Is it visible? Same cloud is visible. You find it small. Yeah. So today your first class is there. So
Yes, sir.
have you studied this basics mathematical tools?
Which one, sir?
Okay, you have not started even physics, right? Any chapter
No,
from the
sir.
physics? Okay. So I'll be starting with your basics tools. I'm not covering the whole chapter of units and dimensions. I'll be just going with the basic mathematical tools. Okay.
Okay, sir. But, sir, I can't hear you clearly, sir.
Okay. That's okay. Hello. Am I audible now? Bhavana, is it clear right now?
Your voice is a little low, sir.
It's low, right? Hello, Bhavana, is it clear right now?
Yes, sir.
Okay. So I'll be starting with your mathematical tools. So basically, in mathematical tools, we are going to study the things which will be required in further physics. Okay. So I think out of these, you are well aware with the trigonometric, right?
Yes, sir.
So I'll go with the trigonometry first. So trigonometry, basically we have three main ratios we discuss in trigonometric. We generally discuss about the ratios. Right? So we have some common ratios. What are those?
Sine, cos, tan,
Sine,
secant, cosecant,
cos, tan. These are
tan.
main, right? These are main. So we can rest of
Yeah.
them we can have some kind of conversions from one ratio to another ratio. Okay?
Yes.
So basically, if so these ratios all are defined for some particular angle, defined for some angle, right? So what can be that angle? Okay. What is angle basically? Line is there. The whatever this is called angle. Okay? Line between two intersecting points. Okay. Now this angle can go from 0 to 360 degree in a whole rotation. Okay. So that's the thing. So if we just take, if I just take this part for a while, let's take some shape. Okay, let's see this one, and you have this one. Okay, and if I want to make some curve, let's see if I have options for curve. No. Okay. So let's say this is your curve. Can I say this is angle theta, right? You know, if I
Yes, sir.
say what is this, so you will say this is a arc, right? If I make a circle out of
Yes.
it, this will be arc. So let's say the arc length is L2. Okay, and at this point, let's say due to this one, arc length comes out to be L2, right? So
Oh,
if I ask you, what is arc length. So you will say arc length is nothing but whatever the radius till here. Let's say this is R1
Yes.
and this is R2, right?
Yes.
So you will say L1 is nothing but R1 times of theta. Is it?
Yes.
And similarly, I can say L2 is equals to R2 times of theta. These things are there. Now, if I wanted to calculate theta, if you see, what happens here is my theta is constant, right? That is L1 by,
Yes.
for the same theta, I have different ratios, L1 by R2, and here I can say L2 by R. Is it?
Ah,
These things are there. Okay. Um, Now, what is the unit of this theta? Unit of this theta is nothing but radian. Okay. Theta is
ah,
represented in two things. One is radian and one is angle. So in general, the unit is radian. Okay.
okay, sir.
In angle, you can go from 0 to 360 degree. In radian, you have different sets of values. We'll discuss it here. Okay. Now, angle
Oh,
can have two directions. Two directions. What are those? Anti-clockwise. Okay, and clockwise. I won't say whether which one is negative or which one is positive. Why? Because it's up to us. Like in general, what happens is this anti-clockwise is taken as positive
okay.
in general, not always, but it's up to the reference also. Like we can change on the basis of reference. Clear
Okay.
till here?
Yes, sir.
Okay. Now
But
assume.
theta can be measured in both ways, like radian and angle.
Yeah, yeah. Look now, I have written here that theta can be measured in your radian and in angle both. Both ways are there.
Oh,
Okay. But let's say
okay.
if I like whatever you are calculating here, if you calculate L by R now, whatever answer you are going to get, this unit will be radian. Okay. This
Okay.
won't be angle. Understood this properly.
Okay.
Because for theta, if you put angle, when we are going to get a particular ratio, when we will put with some sign, okay,
Yes.
understood. Then we are going to get these kind of ratios.
Okay, sir.
You know it. Let's go further. Now assume if I rotate by some anti-clockwise direction. I'm going in anti-clockwise direction. What is anti-clockwise? This is your clockwise, so this I have to go. This, yeah, this direction is your, which kind of direction it is? Anti-clockwise.
Anti-clockwise.
Basically, how we consider it as anti-clockwise, we take a general two-axis plane. Let's say this one. Okay, and here we have another axis. Okay. So generally, whatever most of the time we measure from the positive x-axis, and we go anti-clockwise. Okay, that's why we are saying we are going anti-clockwise. Clear? So if you see in the diagram which we have already represented above, what you can figure out there, that theta, whatever the theta was, that is given as length, basically
Yeah.
arc length, right? That is how much arc length, yeah, arc length divided by radius, right? That was the thing in
Radius.
our case. Okay. Just assume I'm going to take this theta to semicircle. For example, leave it here. If you see in the previous case, I had taken just this line, right?
Yes.
Yeah, this was the case. What is the angle in this case? You can see some angle theta maybe. Okay. Now what I
Yeah.
will do, I will take it to my this thing. You know this is 180 degree, right?
Yes, sir.
So I can see what is the angle in this case. There's a pen. So this becomes, I
One.
can say, yeah, this is some theta. I know the value is actually 180 degree. Is it?
Yeah.
We can say this part.
Yes.
Okay. Now assume what is the arc length in this case. If I ask you if I have to make some arc, what is the arc length in this case? You will say maybe like this is the radius. Okay, this was some radius. So whatever the arc length you are going to create, what is that? This is the arc length, right?
Semicircle.
Basically the
Mm.
perimeter, right? What is that? 2 pi r, and divided by what is the
Yeah.
radius? What you have got here?
Ah.
No, actually this is
2
semicircle,
pi.
right? So it should be
Yeah,
just pi r. So you are getting pi r, that is
pi.
3.1. So what does this mean? That if your angle is theta, right? Basically here you can see my angle is 180 degree, is it?
Yes.
But you are getting value pi. But ideally you should have got 180 degree. Is that?
Yeah.
The problem is this ratios with respect to, if you directly say theta equals to ratio, this will return you the radian value. Is that clear?
Okay.
It is not a what I can say degree. So I can
Okay.
say I know in degree this theta is nothing but 180 degree. So I got one measurement that my 180 degree is nothing but 1 pi radian. Clear?
Yes.
Also, this pi can be written as 3.14 or can be written as 222 by 7. Okay, these are mathematical conversion just for a pi, but the radian, 1 radian basically, 1 pi radian is equals to 180 degree. Or you can say 1 radian, just 1 radian, not pi radian, is equals to how much? 180 degree divided by some mathematical unit, 3.1. Okay, clear?
Oh, okay.
So,
Hi Aditya, I'm sorry to disturb you. Hello Bhavna, good evening.
Hello, sir.
Yeah, it's okay. I have texted you something with your personal message. Okay.
Your voice isn't audible, sir.
Am I audible now? Yes. Hello.
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 Aditya, am I audible? No.
Yes, yes,
Yes,
sir.
sir.
Yeah, I was saying that I texted you something on the Zoom meeting chat for now. Okay, just go through that and do the necessaries. Okay.
Okay, sir.
Okay. Sorry, Aditya. Please carry on.
Wait, what happens is now? From where I got called? Bhavana, is it from your side or from my side? Hello.
Hello, sir.
Yeah, I think. What was that? Like I didn't see any new participants.
No, sir.
Aditya, I joined it with that Chanakya tutorial wala account only. I'm also
Okay,
teaching.
okay, okay.
Yeah, so
Understood,
that team
understood.
with your name only. Yeah. Okay. Carry on.
Okay.
So it's like there's some message.
Yes, Bhavna. Did you receive that?
Yeah.
Okay, fine. Just do it necessarily after this, okay? The analytics marketing fine.
Uh, I didn't understand a lot, but should I continue?
Yes, please. Sir. Thank you. Sorry for that.
Okay, fine, no problem. Okay, so yeah, this is what we are going to get the value. So you can say this is my conversion of 1 radian. Is it clear?
Yes, sir.
So if you just solve this one, 180 degree, 180 divided by uh, 3.14, right? If you do
Yes,
this,
sir.
you will be getting something around 57.3 degree. Okay,
Hmm.
so 57.3 degree. So this is one conversion we have. We can say 1 radian is equals to this much degree. If in further cases, let's say we are given 2 degree, 3 degree or something, so we can convert it on the basis of that. Okay, so
Okay,
that's
sir.
it. Also we can have a interconversion also. So if I'm saying that it is equals to this, so we can say 1 degree equals to 1 by 180 radian. Clear?
Yes.
Is it? No, it should be 180 this. Okay, you can see how small this value is, right?
Yeah.
Okay. So that's the thing. um, these two forms. Okay, let's take it for the exercise. Now we
So
did
it's
it.
like 1 radian is equals to 180 by pi or like any value.
No, no, it's pi, right? It was pi.
Okay.
Look, what
180
happened
by
is,
pi.
yeah, we got this ratio, right? But then we calculated, because we calculated for this value because we already know what is the value we are going to get. Is it? Because we know
Yeah.
the length in this case. If you don't want to do this method, what you can do, you have to do measurement in that case. Just take one line, one line, you should know that this length, you should know this length, and you should know this length also. Okay,
Okay.
and this angle also. Then in that case, you can get a relation between radian and degree, but in different
Okay,
formats.
sir.
Just like I have got in 180 degree and pi, because I use 2 pi r, because I know if this is the radius and the total arc length is going to be nothing but the parameter itself, right? And I know this angle is 1.
Yes.
So that's why we have got this relation. So this is nothing but 180, like 1 radian equals to 180 by pi. Okay,
Okay, sir.
maybe if you will be doing some with other method, for example, you are saying, okay, I'll measure my angle, whatever my angle is, I will measure this length also, then I will take this relation. So might be instead of this you will be having some different theta, and here instead of this pi you'll be having some different numerical value. Okay, at
Okay,
the end
sir.
of the ratio will become 180 by pi itself, some in some way.
Okay, sir.
So that is all right. So now we can move ahead with the major trigonometric ratios. Wait, if I want to export this value. Now, from here we are to the trigonometric ratio. You can see in just before the introduction, we have just going with a normal trigonometric, and we have just discussed about the angles, right? Now we will discuss properly
Yes.
the ratios. So for this ratio, what I'm going to do, I'll take right angle triangle. This is what I have. So some different angle. I took,
So there's some disturbance.
yeah, I know, there is disturbance. So which one is that? Yeah, this is 90 degree. Okay. Okay, this is 90 degree, and let's say this is your angle theta. Now, if I ask you, let's say this is for, look, one more thing, for any theta, what is going to be perpendicular? The one who is just in front of them. This is going to be
Yes.
perpendicular for this, and below one will be base for him. Okay, and the main is hypotenuse. You know. So we know this
Yeah.
relation that p square plus b square will result as, is it?
H.
Okay. So as per the trigonometric ratio, we have three kind of basic trigonometric ratios. Sine of this theta will result you perpendicular upon base. Cos of this
Yeah.
theta will result you base.
Hypotenuse.
Yeah, that's what I understood. Here cos theta will result you base upon hypotenuse, and the rest, like, okay, tan is basically ratio of sine
Sine
theta.
by cos.
Okay, and that results as what? P by h,
P
right?
by B.
P by b. These three are main ratios. Okay, apart from this we can have different similar kind of ratios we can consider. For example, one is 1 cosecant theta,
Reciprocals of these three names.
reciprocal of this will be nothing but reciprocal of cos, and this one will be reciprocal of cos.
Cot.
Okay, I think you must have studied all these part in your um,
Yes.
grade 10th itself, right?
Yes.
H by b, and this is nothing but b by. Okay, that's fine for now. Like one important angle you should know, that is either 37 degree, either 53 degree. These two angles you should know. Why this is
Okay, sir.
special? Sine of theta, basically sine of 53-degree gives you 4 by 5, and cos of 37-degree gives you how much? Again 4 by 5. Clear?
Forward.
So if you have angle like this, so if this is theta, let's say 37 degrees. So you can say sine of 37 degree. What will be the sine of 37 degree? 3 by 5.
4.
And cos of 37 degree, again 3 by 5. Clear? These two angles are important. We can write this as, what we can write here is the front of this, 3, 4. Understood? This isn't just
So cos 37 to 3 by 5?
no, no, not where did I miss? No, it should be 53.
Okay.
It should be 50. Yeah, it should be 53. And it should be
Mm,
cos of 53 degree. It's an obvious thing also, right?
yeah.
Um, okay, that is fine. So this is going to be your 53. So you can also say that, okay, what is cos 53? Something with this base. Okay. So just you can remember this triangle. If you get confused between whether it should be 3 by 5 or 4 by 5, you know one thing, like either it can be used for cos like 53, or can it be used for sine, right? 37 degree, right? But you have to
Yeah.
see carefully. If you have sine, you know sine the sine value gets increases, right? It goes from
Yes.
37 to this. So you should know who is the greater. This is greater. So this should be for sine of 53 degree. Okay, this is how you can understand if you
Okay,
just
sir.
get confused in this thing.
Okay.
All right. So other trigonometric identity we can go with this. First is sine square theta plus cos square theta results you one. 1 plus tan square theta gives you secant square theta. Okay. And the last one is 1
1
plus
plus cot square
cot,
theta.
cot square theta gives you cosecant
Cosecant
square
square
theta.
theta.
Okay. Apart from this, we have some more identities. For example, um, sine a plus b, sine of a plus b. What it is? It means sine of a multiplied by cos of b. Okay. Plus sine of b cos of a. Clear? In the next case, you can
So can
put
you explain that
the
again?
derivation of it.
Okay.
No, no.
Yeah. Yes, sir.
Look, what does this mean is, if you have this kind of ratio, what you can do is simply put sine of it. What is sine of a? Like start with any angle you want. You can take start with first one. Okay, who is that? Sine of it.
Yeah.
Then what you have to do? Take cos of the other angle, summation, and whatever
Okay.
the sign convention is. Okay, let's say it is negative, it is positive. So I'm using plus minus. Okay. Then you can start with this. Take the sine of the other angle and cos
Okay.
of the rest of them. This is what the formula is. For
Okay.
cos, for cos a plus minus b, look in cos what happened. Cos is kind of greedy, so he will go with a c and c first. Okay, so mean to say
Okay,
cos
sir.
of a, cos of b. But greed is not always good, so he have to go with a negative convention. Mean to say for positive the sign is negative, for negative it will be positive.
Okay.
Then the other way. Okay, this is one thing. Other formula is sine of 2 times of theta. What does it mean? You can use this formula. If you use directly this formula, you can see I can write this as sine of theta plus theta. Is it?
So I can't see that.
I
I can
think.
just see just till there. Sine A plus B.
Oh, wait. I think this page is. Hmm, wait a minute. I should save this one first. Then I will move to the next page. Okay, wait.
Okay,
I
sir.
have options to get new page. Fine, fine. I can get. I got new page. Where I left sine 2 theta. Right. I'll just remove it from here. Until where you can see it.
Sine of A plus B.
Sine of a plus b, cos of a plus b. Okay, I will remove this sine and cos both from here, and we'll do this in the next page. Okay.
Okay, sir.
Second. So I have written sine of A plus minus B. What was that? Sine of A times cos of B plus minus cos of A. And what is the next one? Sine of, clear?
Sine of B into cos of A.
Yeah, whatever, like the same thing, right?
Yeah,
It is on
yeah,
the multiple.
yeah.
And the next one is cos of A plus minus B. I said cos is a
That
kind
I
of,
didn't see, sir. Cos of A plus.
now it's clear, right?
No, I can't see.
But still you can't see cos of A plus B. I have changed the page.
No, no, sir, I can't.
Wait, I have changed my page, still you can see this.
I can just see that Aditya did pinpointer.
Okay, I think you can scroll it, right? Little bit up. What's
No,
your...
sir, I can't.
Okay. Can you see now?
No, sir.
Why this is happening? Actually, I am
Yeah,
first.
yeah, yeah, I can see it now.
Now you can see, right?
Yes, sir.
Okay, great. If I'm writing, I'm just scratching normal. Can you see this?
Yes, sir. Yes, sir.
Okay, now it's fine. So this is your cos A plus minus B. That is again the greedy person will go whatever
It
to the...
depends upon the value we take. If we take plus, it will be plus.
No, no. Look, if it is a plus here, right? So it will go with a minus first. If it
Okay,
is
okay,
negative, then it will go with the first. You can see here
okay,
for a positive, negative. Here positive, negative. Mean to say for positive, here is positive, and for negative, here is negative. It is positive,
okay,
negative, negative, positive. Okay?
okay. If it is like cos of A plus B, it's cos A cos B minus
Minus
sine A sine.
sine.
Okay,
That is it. So look, I
okay.
have another is sine of 2 theta. What is that? I can write this as sine of theta plus theta. Is it?
So is it like cos A cos B?
Which one? This one?
Cos of A plus of minus B.
No, no. Look now. If you see now, I have converted it into two things, right? Sine of a plus b.
Yes,
So I can directly use this formula, right? So you can see instead of this a and b, I can put the value theta and theta, theta and theta. So you can see I have same thing: sine theta, cos theta, sine theta, cos theta, and I am adding this. I am adding this. So what I am going to get? Two times of sine theta, cos theta.
yes.
So that is the thing. We'll do the same for the cos also. It should be positive. It should be b. B I already, yeah, B I. Then we have cos of 2 theta. What we can do, cos 2 theta again can be written as cos of theta plus theta. If you put the value, right now, if you see here I have cos square theta, it will become cos square theta, it will become sin square theta. What I am going to get final answer? Clear?
Yes, sir.
If you want to do, it's up to you. You can do another conversion also. You know that um, cos square theta plus sin square theta is nothing but 1, right?
Yes.
So if you want this into just in the form of cost, so you can do one thing. Instead, you can substitute this value. Sine square theta is nothing but 1 minus cos square theta. If you put this value here, what you are going to get 2 times of cos square theta minus 1. Okay, and the vice versa also.
Abacus.
If you want it in another form, so you will get this one. Clear? Just check it once. If you are clear with this, then we can move to the next one.
So should I have to note down this all everything?
No, I'll send the PPT. Okay, it's up to you. Like you can just remember all these things. Okay.
Okay, sir. Okay.
Basically, we
Like
may,
you'll be sending it after the class.
yeah, after the class we'll get the PPT. Okay.
Okay, sir.
Like even if you don't get the PPT, maybe I'm first time I'm using this board, so I'm not sure whether I'll be able to export this or not. So if you don't get, don't worry. If you just go to the internet, you can directly get the whole sheet of these kind of things. Okay,
Okay, sir.
just these are just ratios, not very high concepts.
Okay, sir.
So yeah, by here we have done this thing. Now we can discuss some angles. Okay, the important angle.
Okay, sir.
Okay, for angle, I will go till 0 to 180 degree. Okay, for each of them.
Okay, sir.
Like, so we can start from, we'll make a table first. And wait, I need 0, 30, 45, 53, 60, 90, 120, okay, 150, then 180. Two more blocks I needed. One extra I'll take these things.
Okay, sir.
And we will do the discussion of all these for two different things. One will be a cos, one will be a sine. Okay.
Okay.
So this is your computer. So if you see, my first column is basically your angle theta. I'll be putting angles here. Here you will be having the sine of this particular angle, okay? And here you will
Okay,
be
sir.
having cos of this angle. So, so first is 0 degree, okay? Then you have 30 degree. Then you have 45 degree. Okay, we can add one more thing, 37 degree, right? Okay, let's not
Yes.
add 37 degree because that didn't give us the direct pattern. Okay,
Yes, sir.
do it for some measure like 15 or 30 gap. Then you have 90 degree. After this 90, 30 degree gap, 120 degree, 130 degree gap, 150 degree, and 180 degree. Okay, that's it. We will discuss whether we have to go after this or not.
Okay, sir.
So the first is sine. Sine 0 is 0 itself. And how you can write it? Simple. It's a simple thing. Start with, put 1 by 4. Not just till 90 you have to do this. Okay, don't do it afterwards.
Okay.
From 0 to 4. 0, 1, 2, 3, 4. 4 to 1. 4 to 0. Put under root. This is the value of your sine, whatever the theta is given. Okay.
Okay.
And after this, what we have to do? It depends. Let's see. Okay. Now I'll give you. I will just show you the graph of sine and cos. Wait. Maybe I have option or not. I'll see first. Just a minute. Okay. Let's see if I can make the graph. So this is y angle. It's sine of. I'm sharing my total screen. Okay.
Okay. So,
No, wait. If I do this, the whole screen will get. I have to save it first. How can I save it? I still don't know. Okay,
so like
maybe.
just
Yeah, what? Okay, wait. I will do. I'll just get the photo of it. Maybe. Can I add it in the picture or not?
so I just have idea up till 90 degrees. So
Okay, yeah, I know. Okay, maybe I can make it here itself.
yeah.
So just assume I'm making for sine first. Okay. So this is sine. Okay, and this is your y-axis. Now it seems good actually. So let's say this is one. This is two. I can say this three, four, and five. So if I say this is 30 degree, 60 degree, and 90 degree, 120 degree. Okay. No, let's
Okay,
make
so
it 15 degree gap. So then I have to say this is not this way. But 1/2. If I say this is 1/2, then I can say this is another value, or I have to get 2 degrees of gap. Okay, let's do one thing. Make a bigger block, not this. It's not a good way to make graph. This. Hmm, maybe this. From here. I'm not going to be in the negative side. I will try to be at the positive because negative is basically the
okay,
flipped
so
version of it. Okay, this is the flipped version. Of it. So mark some points. Let's say this is 15 degree. No, this is 30 degree. This is for 60 degree to 90 degree, to 120 degree, and so on. Okay, so till here we will start. So for 120 degree, let's say this is the value point here. For 60 degree, this value is somewhere around maybe okay 1/√, so it will come up here. Okay, then this will come up. It should be here. There is an easy method to write make this graph. No, not this. Did I make mistake here? Okay, wait. This, then this. No, wait. It is just increasing till 90 degree. No? So if this is this value, this should go. Let's say this value, just a one-off change. If this goes to this, we will be having a straight line. I think something. And then finally you can say this. Yeah, it seems to. Okay, look. So
so it
something.
is for sine.
Yeah, I'm making it for the sign. Uh, what I can.
Okay.
I need four division, right? Let's say this is one, this is two, this is three, this is four.
Does that mean that the value is increasing from 0 to?
Yeah, actually, for value increases. Okay, okay. I'll just make a
Yeah.
rough graph.
Okay.
I'll make a very rough graph.
Because it decreases, right, sir?
Okay. Look, if you see carefully, my sign for the zero, right? I'm at the 0 degree right now. My
Yes,
sign
sir.
started from 0 degree, right? With a zero value. So I know this is the point.
Yes.
After this, it increases. How it is increasing? Let's say this is 30 degree, 60 degree, 90 degree. So till here it is increasing. Let's say this is 1. So by this way, it is going to be at 1. This is increasing. Okay. In this region, it is.
Yes.
The graph is not like I don't get any option to make some curves. Yeah, this is one thing. After this, what happened for next 90? If you see, to go from 0 to 90 degree, how much interval it needed? 90 degree, right?
Yes, sir.
Basically, from going 0 to maximum value, it needed 90. So from coming back also, it will need 90. So what will should be the next? This is 120, this is 150, and this is 180.
Wow.
So come on. Now, why I didn't told you the further values for this part? Okay, yeah, I had just mentioned one extra. Okay, leave this part. What will happen here is this is the central part. Okay, if you see, both sided seems to be symmetric, right?
Yes, sir.
So I can say if it is a symmetry, all the values is going to be repeated in the further part. Okay. How? For example, let's say this is the 30th value for the 30th, right? Whatever the graph is there at this part, ideally this 150. Ideally this should be 150. Okay.
Okay, sir.
For the 60, this is the point.
So the points meet somewhere.
So these points are meeting. Maybe this. So you can see this is somewhere touching with
Yes.
the 120. Okay. All right. And yeah, you can see. So I can do one thing, 30, 60. So instead of 150 degree, I can put the value of 30, right? I will go at 150, I will put the value of 150 as 130. 30 is nothing but 1 by 2.
Yes.
Clear? For 120, it is 60 degree. So root 3 by 2. For 180, you can see that is 0. So 0. Clear till here?
Yes, sir.
Now, what I wanted to do is, I will take this whole thing from here. Maybe if I can copy this to picture. This, do I have option to, why I can't turn it upside? Mm, no, I wanted to turn it upside actually. Okay, look, what I wanted to do is, I want to go further. Okay, if you see, I need 0 to 180 degree to make this curve, right? So in the
Yes,
next,
sir.
if I just extend this, can I increase? Let's increase this one. Okay. After this, this is 180 degree. This will be 220. This will be 240, 270. How much is the next part? 300 and two more. 330, 380. You can see I have given up another 180 degree division, right? So whatever the
Yes,
graph we
sir.
had make here, I have to make it downside also. So 1 and 2. This is 1, this is 2. I have to take this as the maximum value downside also. This should be the point of maximum value. This is
So
the thing.
the are these
Yeah, what happened?
these are all the part of this units and dimensions. So
No, actually, it's not a part. I'm just explaining this how these values actually looks like. Okay, in the graphical method
okay,
also.
okay, okay,
Basically, look, units and dimension covers a lot of things, and this is right now. I'm not even doing units and dimension. I am going with the mathematical tools which you
okay,
may require in the future. Okay,
okay, okay.
so this is the sine curve. Okay, sine curve basically start from zero, and this is the curve. In simple, like in general, you won't be doing this. You can simply make like this. You know, for 0 to 90, the whole thing is positive. For 90 to 180, the thing is negative, right? You can see because it is below the line. Okay,
Okay, sir.
your 230. Look, what you have to do simply to get the values. You know, after this, what I am going to get, that is positive, right? Negative, but the magnitude will be same. If I just flip the whole thing, if I just take the whole thing and make it upside, if you see, if I say this is a mirror, which value I'm going to get? This is same thing I'm going to get, right? Which these things, right?
Yes.
So if you want to put values, let's say you have given, give me the sine of 240 degree. How you can do is simply, you know, this is nothing but greater than 180 degree, right?
Yes, sir.
Subtract 180 degree. What you have to do? Subtract 180 degree from here. Whatever value you have got, that is how much? 60 degrees. It,
Yes, sir.
you know, sine 60 degree.
Root
Clear?
3, right?
But one
Okay,
more
sir.
thing, you know, this value you only know because of the like you already know that this region should be negative part. So the value what you are going to get negative. Clear?
Okay,
So this is the method you have to follow. So okay. After this, I'm not writing any values. Okay.
okay, sir.
Uh, I can say okay. After this, you can say your whole values. The total values getting repeated after 2 pi. Is it?
Yes, sir.
Sine values are repeated. Like all the values. Look, I'll just make this silent for a while. Yeah. If I ask you what is the time period, so period here is t, 2 pi. What is the time period? That no,
2
this
pi.
is the time after which the value recurs itself, right? So you can see that is 2. You can't say okay, I am recurring the value from here also. 90 degree after you are getting the similar values. It's not the thing, okay? You should get the similar whole interval also. Okay, so you will be getting the same interval after this, completing this part. Okay, from here again you will be starting with the 0 to more, then for this. Is that clear? This is how
Okay.
you are going
Yes,
to get
sir.
the same values. Just one thing is reversed. In the cause, what will happen? My axis will become this thing. Okay, understood? If you see sine the cos, right? For cos zero is 90 degree, the maximum value, right?
Yes, sir.
And rest we are decreasing. So here, if you see zero, if I say this is zero, this is the maximum value. After this, I am decreasing, right? And this is the 120 degree. So for cos, what happened is I'll just make cos from here below of it. Okay, for cos, what happened? From this reason to this is 0, this is one reason, this is another reason. So you know this is 0, this is I'm saying 90 degree, this is 180 degree, and 270 degree. Basically, it's 90 degree of interval. Somewhere here you will be having 360. So you see, from maximum you are going to 0, and after 90 degree here you are getting how much? Negative values, something like this. Okay, after this again you are going upside, and so on. Clear? So for cos 0 to 90, no, basically you can say 180 to 70s, the 270 is the reason of negative values. Okay,
Okay.
that's it. If you see, if you want, you can get the magnitude is still the same. Okay, if you calculate for cos of let's say 120 degree, right? What you know 120 degree is related to 60 degree, and what was the cos 60 degree? 1 by 2. So what is 1 cos 120 degree? That is also 1 by 2. But this is below the line, right? So that will become minus. Is that clear?
Okay, sir.
These things, how you can remember these values. So I'll replace this whole thing. Yeah, let's come up for the sine part. Simply, you should know the sine values from sine theta from 0 to 90 degree. Okay,
Okay, sir.
understood? That's it. Now, if I ask you what is the sine of 180 degree, how you can get me this value? Look, whatever value you are going to get, one formula you have to remember. What is that? Sine of minus theta is equals to sine theta itself, negative of sine theta, cos of minus theta equals to cos theta. Is that clear? If you have negative sign inside cos, that doesn't matter. You can write that as cos itself. Okay.
Okay, sir.
Now let's say if I'm asking, give me the value of sine of um, 270 degree. What you will do in that case? Very simple. You have to do whatever the angle is given. Subtract this angle with 180 degree. Okay.
Okay. It doesn't matter if we get minus sign.
I will get your answer. You will be getting minus 90. Is it?
Yes,
What is
sir.
this minus 90? You will be getting minus sine of 90. What is sine 90? 1. Answer is 1.
One.
Come up back. This 90, the sine 90 gives you this magnitude value, right? And this negative gives you the directional value. Got it?
Okay, sir.
But you can't do the same thing in cos. Understood?
Okay.
The reason is for cos, we have a different reason. What is that? If I do cos, okay, if I let's say maybe my cos is, yeah, this is the cos part, right? Let's say I wanted to calculate cos of 120 degree. Then how what I should do here? If you see carefully, for cos, my things are changing with the first thing changes with 90 degree, right? Can you see this?
Yes, sir.
I am getting first zero after 90 degree. So what I will do, I will try to make it into the sine. If you see, can I write this as cos 90 plus this 30 degree?
Yes, sir.
And what is 90 plus 30? That is minus sine 30 degree. Okay. Yeah, one more thing I'll just give you. Look, this is the first reason where all your sine, cos, and tan are positive. This is the reason where sine is positive. This is the reason where cos is positive. This is the reason where tan is positive. Okay.
Is it like all silver teacups?
Yeah. Um. Wait. Wait a minute. From 90 to 180 degree. Yeah. That comes out to be negative. Wait. I just made mistake here. This should be sine, tan, cos. These are their reason. Here all of them are positive. Here just sine is positive. Here just tan is positive. Here your cos is positive. Is that clear?
Okay.
I'll just give you a hint. If you see where is my sine positive? Sine is positive in this 0 to 90 and 90 to 180. Let's come up to the graph. This is the reason, right? 0 to 90 my sine is positive. 90 to 180 my sine is positive. Clear? Cos, where is my cos positive? Cos is positive in 0 to either 90 degree and 270 to this value. Yeah. So here if you see this is the cos. 0 to 90 it is positive. After this, the reason of 90 degree to 270 it is negative, right? Here you can see from here to here the whole angle 90 to 270 it is negative. Is it?
Yes, sir.
And the last this portion comes out to be positive. I will remove this and I will tell you how for the cos you will be using this parameter to get the value. Okay. Look, you have two options. Either directly remember all the values from 0 to 360 degree. Okay. Other option is you can go with a proper conversion. If you know the conversion, you will be able to do this. Okay. So I'll just come up with you within a minute. Okay. Fine. Now just tell me, have you studied this formula sine of 90 minus theta? Hello Bhavna, have you studied this formula sine of 90 minus theta?
Is it like cos theta?
Yeah, exactly. It is like cos theta. Why this happens is when we are conversing. Look, one more thing. For sine or cos or anything, this 90 changes the term. If this is 90, it means sine is going to be in cos, cos is going to be in sine. Okay. If it is 180,
Okay.
then you don't have to change. Just your values are going to be changed. Okay.
Sine 180 minus theta is equals to theta.
Yeah.
Like
Like for example,
sine theta.
yeah. Like if it is written sine of 90 minus theta, then what it is? Cos theta itself.
Cos
Okay?
theta.
And sign convention, you have to check whether in this particular reason whether your sign is positive or not. So you can see your sign is like positive in in the first quadrant, right? And this value comes in the first quadrant. So whatever the value is positive. If you have given, let's say, sine of 270 degree, let's say 240 degree, okay, then what you can do here? Any idea? I told you for this you have option to use 180 degree, right?
Yeah.
Either 180 degree you can use, or either 270. 90 and 270 are the changing reason, because this is a proper multiple of like these two act as a 90 degree. Why? Because here your 90 lie, here your 270 lie. Okay. Here your
Okay.
180 lie, here your 0 degree lie. Basically 0, you can say, if you see in this way, this is 2 pi. So for these, your term doesn't changes, but for these two your term gets changes. Like if it is sine, becomes cos, cos becomes sine, tan become cot, cot become tan, on the basis of whether they were positive in that reason or not. Understood?
Okay, sir.
Okay, so I'll just remove the whole thing for now.
So these are two formulas.
Look, this is just a one thing. Okay, now what you can do, you can make your like formula for this. For example, if I have something like sine 240 degree, right? But you only know values from 0 to 90, then how you can put this value? You know one thing, I can write the sine as pi plus how much is the rest part, 60 degree, right? You
Yes.
also know I can write the whole thing as sine 60 itself, because I have pi, so I don't need any conversion. But wait, this is pi. Pi plus 68 means I am going in this region. Just you have to make like this. Okay, you don't have to properly make. Simply you make here a small graph. You can say, okay, this is 180. Adding 60 degree, I am going in this region. In this region, my sign is negative. Whatever you are going negative. You know, sine 60, just put the answer. Get it? Got it?
Okay, sir.
You can do the same for all the things. So right now, I won't say you to remember all these values. For example, you have to calculate 120. Cos of 120, what is it? Cos of 90 plus 30. This is cos 90 plus 30. In 90 plus 30 mean to say you are going in this region. Cos is negative here, minus, and this will become sine 30. Answer is 1 by. Clear?
Okay, sir.
This is how you can solve these problems. And this will become root 3 by 2, and this will become 2. Understood this part?
Okay, sir.
Look, by here I'm done with the your mathematical tools for trigonometric part. Okay, not for everything.
Okay, sir.
In the next class, I will discuss differentiation, integration, some more important part. Okay, and look, rest of the trigonometric thing we will do in the session itself, like when we'll be solving some particular problem. So there we will see that those formula. Although because if I stuck into the sign, we have too many things. The whole chapter is there to study. Okay.
Okay, sir.
So this is all for the today's class. You will get the
Okay.
PPT of these 2 pages, whatever these are. Okay.
Okay, sir.
So goodbye. This is all for the today's class. I'm ending the
Okay, sir.
session.
Okay, sir. Thank you.
Yeah, thank you. Goodbye. Yeah, you can leave. Okay, I'm just downloading the things and all.